Hey there, everyone. Today, I want to talk about a unique concept that I came across kind of recently. I think I discovered this a while back, but I didn't really pay attention, didn't really dig in until somebody explained to me that it's a major problem for themselves. And I thought for a second, let me pause and see how big of a potential problem is this thing really. I think I've discovered this or it's come up on my radar at some point in the past, but I never really dived into it, so I didn't really know how much of a pain in the butt this can really be. But this concept actually has a few different names. It's name normalization, also known as label consolidation, also known as entity resolution, also known as data deduplication. So in any kind of environment, we always want to deduplicate things. We don't want to create duplicates and triplicates and quadruplicates of data. That's kind of insane. I've seen that done before. I'm not sure why people do that, but we don't want to do that, right? We don't want dupes in our database and our data sources and our spreadsheets or AWS or Azure databases that we work with on the cloud, right? We want to deduplicate data, but sometimes you'll get data that comes from many different sources that actually is not duplicated, but when you start to combine it, you create your own duplications, sort of as a course of doing business, kind of accidentally. But there's ways to handle that and to treat this efficiently so you don't end up warehousing lots and lots of duplicates that are essentially the same, but you keep only the unique records that you need. And I know for a fact this is a problem in businesses like credit cards, right? Credit card companies have to deal with purchases and sales transactions all the time. And different credit card companies will represent different transactions slightly differently or wildly differently, right? But we can standardize this data so it can be consumable and digestible by a normal human being without creating frustration and stress for the data management team and for the reporting team and the data scientists and the engineers and all this stuff, right? So let's say we have a list of data that comes from different credit card companies. I won't name any names because I don't even know exactly how they do this, but I know that they do something very similar to this, right? So a credit card company can record a transaction at Starbucks coffee receipt. It could be called Starbucks coffee purchase. It could be called Starbucks coffee small. It can actually have the name of the town where the transaction occurred. All right, so we have Boston, New York. Here we have a food purchase. Now this doesn't look like Starbucks. This looks different than Starbucks, but certainly Starbucks sells food and they sell brunch items and items fit for human consumption, right? So this could be Starbucks. It doesn't look like it. I'm going to say it's probably different. And these transactions look very different from Starbucks. I don't think Starbucks is selling clothing. There might be a handful of exceptions, but I'm going to go out on a limb here and say they're not selling clothes, no pants, shirts, socks, or hats for men. So I think these are different transactions. Now, again, they could be coming from the same credit card company producing these transactions or come from a different credit card company, right, that has different naming conventions and a different way that they collect their data and report on their data. And this is fine. It is what it is, right? So we'll just try to come up with a couple of techniques to manage this process and make sense out of it so we can alleviate any pain and frustration and headaches dealing with this data, right? We want to make it as seamless as possible and streamline the whole reporting process, right? Or data collection process or data science and predictive analytics process. Whatever you're doing, we want to try to make it as easy as possible. Okay, so there's a couple of techniques. These are just 3 of the more common ones. There might be other ways to handle this, and that's up for debate too. We can sit down and discuss this. You could meet with your team and say, what alternative methods could we consider? But I think these 3 that I'm going to introduce are probably the most common here. So we have something called fuzzy matching. So I've introduced this in a couple other videos. This basically looks for similarities of words and tries to look for words that are spelled substantially similar and match those together. And if the words are different, those will be matched with other words that are similar to those words but different from the non-matching words, if that makes sense. Okay. So we have the categories. I put everything into a nice little dictionary. So we have the key value pairs. Here's the key, coffee, food, clothing, and here's the values. So a dictionary has key value pairs, a little bit different from a data frame or a list in Python, right? I talk about all these data structures in a couple other videos. I'm not going to get into it now because it doesn't really matter. It's just a way to contain the data, right? So I have a small script for all keywords. We have the keyword and the category. So this is the key. right? And this is the value pair. So these keys and values are matched together. And okay, so here's an example of a list. So we saw the dictionary above. Here's a Python list. The dictionary has these curly brackets, and you have the key, and then you have the value, which essentially is a list inside of a dictionary here. And here you just have a pure list. Okay, so I'm going to go ahead and run it. Now, given what we've learned above, we're going to see how fuzzy matching handles this issue, and does it actually handle it or does it not? So we have coffee, food, and clothing. These are the items that I'm looking for. Coffee, Starbucks coffee receipts, pants from New York, purchased in New York. Okay, and then dinner, retail, not a lot of description there, but we know this transaction was for some type of sit-down dinner, right? So we have the match categories, coffee, clothing, and food. And that matches this, right? So this is Starbucks, that's your coffee, that matches that, that's fine. Here's your clothing, okay? Pants, New York matches clothing, and here's your food. So mission accomplished, right? I think that was helpful, kind of useful. Although, I mean, I think it leaves a little bit to be desired. Are we really handling all this mess over here and consolidating that, or getting this fitted nicely into a tight, crisp sort of data structure? Not really. We definitely found the fuzzy matches over here. So I think it's somewhat useful, but I think we can do better. So let's look at another example. This is a clustering technique. We're going to use k-means clustering. Okay, and again, we have the items set up in a list. So we have Starbucks coffee receipt. We have Starbucks coffee purchase, dinner retail, pants, socks with an ampersand at retail. That's how this credit card company reports it. And then we have brunch sales. So we're looking at k-means clustering, TF-IDF vectorizer. So this converts all words into numeric vectors. Computers work very well with numerics. They don't work very well with words. So we have to vectorize these. Once we vectorize it, we can make sense of all of these different items and see how well they cluster together. So let's see, Starbucks coffee receipt goes into cluster 2, okay? And Starbucks coffee purchase goes into cluster 2. Okay, I think that makes sense. So these clusters are a little bit arbitrary, but anything that has Starbucks coffee is going to go into cluster 2. So I think we're handling this case very well. This is dinner retail, cluster 0, pants, New York, cluster 0, and brunch. So I think we we have a problem here because pants is going into cluster 0, and the food items, brunch sales is going into 0, and dinner is going into 0. So I have a little concern with this one right here. This one looks weird. But socks goes into cluster 1. That's nice. I would expect pants to go into cluster 1, to tell you the truth. This doesn't seem to be working. There's a few different clustering methodologies we can try. I believe there's about 10 or 11. There's all kinds of things out there. I have another video that talks about the different ways to do clustering. So we can try a different clustering technique. K-means is not necessarily the best. It's probably the most popular. But it really depends on the types of data that you're dealing with to determine, is this the absolute best way to do your clustering or not? So I'm not going to dig into it too deep. I just made a quick attempt to solve the problem. The first one worked, leaves a little bit to be desired. I'd like more details here. The second one really didn't work because we have pants going to cluster 0 with dinner. So that's not working for me. I'm going to discard this. The first one, I'm going to kick that to the side because I'm looking for a little bit more power here, or a little bit better reporting capability, and it's just not coming through. So I'm going to try a heuristics approach. So what is heuristics? It's a big word. You've probably heard it thrown around a couple times. Maybe haven't heard it. Basically, heuristics is a way to use to do a very quick and dirty analysis of something and get a very close approximation to an actual result, but you can't guarantee that's 100%, right? So it's very quick. It's going to converge quickly and easily. You'll get your solution extremely fast, right? If you do a full-blown non-heuristics analysis, it's going to take much longer, on the magnitude of, I don't even know, depending on your data set. It could take hours, days, maybe even weeks to get a result, right? A heuristic is going to produce a result in a tiny fraction of that time. It's going to be mostly accurate, but again, not 100% guaranteed. But in most cases, it's going to be good enough given the time that it takes to run, and it's going to be extremely accurate, upwards of 99% accurate most of the time. So I think a heuristic is a good approach to try here. So I have the categories again in a dictionary. and I have my words over here. Now stop words I'm going to take out. I don't think that lends anything to the analysis. Like New York and Boston is not going to help me determine the type of transaction. So some companies use this. Purchase, I know all these are purchases, okay? This is coming from a credit card company. A receipt is not going to help me. The ampersand is not going to help me. So I'm taking these out, right? Men, I don't care if it's for men or women. I'm looking at what type of purchase is this. That's what I'm concerned about. Now, maybe you want to know, is this a purchase for a man or for a woman? Maybe that is important for you. In my example here, I'm just kicking it out. I'm saying that's not important. So I just ran that. I don't know if you saw that or not. Control Enter runs it. It flashes for about 1 second. The heuristic is so fast, in a fraction of a second, it's actually done, and it spits out the result, okay? So let's go down and see what it created for us. So we have items, Starbucks, coffee receipt. This is coffee, Starbucks coffee. Pants is clothing. This is the category. Dinner, retail is food. Okay, I like that. Shirt is clothing. Men is clothing. Hat is clothing, right? Brunch, food. Latte, coffee. Okay, that's good. Thought I made a mistake, but actually correct. Socks is clothing and food is food. So there we go. We have 100% accurate. Ran in a fraction of a second, and we have all of our items listed out there, and it's neat and it's organized and it is deduplicated. All the labels are consolidated. The names are normalized and structured, and I think we're in a good spot right now to start moving forward with our analysis. When I look at this at the beginning, this is a big mess coming from 3 different major credit card companies. Okay, and of course it's a very small sample. They're going to send you hundreds and hundreds of thousands of transactions, probably millions of transactions, right? So we want to get that into a state that's feasible to work with, nice, tight, crisp, and everything is buttoned up very nice for you right here. So that's what we get with the heuristic approach, right? So again, fuzzy matching looks for name similarities and corrects for misspelling, and the strengths are handling misspellings and typos. It's very flexible in matching names, products, addresses, all kinds of things, right? But the weaknesses is computationally expensive, and it doesn't always give you the full description that you're looking for. That's what we saw in that first example. And it's not inherently grouping items like the k-means clustering, right? So k-means clustering is great for getting predefined categories of data, right? The strength is you don't need to set up the categories. It's going to figure it out for you automatically. That's why this is unsupervised learning, right? Supervised is classification and regression. Clustering is unsupervised. You don't even know what the outcome is going to be. The computer tells you what it's going to be. You just say, give me a cluster, and it produces those clusters for you. So it's pretty nice in that respect. And it scales to large data sets, although if the data set gets really large, it's going to slow down. And it's going to take a long time to converge, right? So that is one weakness. It does require some tuning, right? You have to set up the problem initially. And these tend to start off with the k-means, and a lot of these clustering, they start off randomly. So if you run it a few different times, you can actually get different cluster outcomes, right? So you might have to run that multiple times until you're happy with the final results that you're getting. If that's sufficient, then you can stop. But it might not be a one and done type of run. It might require several runs. Okay, but the heuristic turned out to be the best approach of these 3. It uses a rule of thumb to find predefined patterns and make categorizations of whatever data you're working with, right, to make ultimate decisions or to help you make improved, more informed, more insightful decisions. That's what we're doing here, right? So it's fast and efficient. You saw the thing run in a fraction of a second, easily to interpolate the results, right? The first example of fuzzy matching, it produced results, but it was really sparse and it really left a lot to be desired. The heuristic approach really gave us everything we wanted, and it's pretty comprehensive and very complete, right? Any kind of weaknesses, it does require some setup, right? And you have to define the rules up front. So it's kind of the opposite of clustering, where there's no rules. The computer figures out the rules automatically. It tells you what the final result looks like. You have to set up the rules, but then the final product is a lot tighter, crisper, cleaner, and it's packaged up in a way that's ready to be delivered to your stakeholders and to your colleagues, your teammates, and anybody that needs to see this stuff, right? So that's it. Hopefully you learned a couple new things today. I learned a couple things when I put these scripts together. I'm going to save this code and share it with everybody. I always save all the code. You don't have to understand all the details of this. You can click it and run it and then take your time and go through it and learn at your own pace, right? It's a little bit too much to get into with every video to go through every single detail of every line of code. I think it would take way too long and I would lose people along the way, so I don't do that. But I try to give you a general overview and take you through the main points of this teaching lesson, what we're trying to achieve, and then how to get from point A to point B, or wherever you're going, however far you need to get to the end to deliver the results that you need for your team. Okay, so that's it. Thanks for your time, everybody. Enjoy the rest of your day.